Okay, thank you. It's my extreme pleasure and honor to let me close the door. So it's obviously live. Thank you. I'm from the University of South Australia. I'm the director of the Australian Research Centre for Interactive and Virtual Environments. The slides I'm showing today are part of a small cut down version of what we teach in our honors class. I should point out Mark Billinghurst actually have made these slides. He loves making slides. So today what I want to talk about is interaction and design for virtual reality and some augmented reality. So let's talk about interaction. But first, an honor student of mine last year, he actually took all these common interaction things, like 30 years worth of them, and he made them into a Unity toolkit. So if you Google 3D UI TK, there's a nice set of examples and applications of some of the interaction techniques that I'm talking about today. Okay, so just a typical VR system here. You have head-mounted displays, you have input devices, you have tracking, but at the center of all these things, you have some sort of user interface. So people have to control this in some way, and that's what I want to talk about today. The talk is a bit foundational. It is a huge open research topic. Finally, we have technology now that works well enough that we can actually tackle some of these problems. So, okay, so why do we want to do this? Well, we have to support the immersion of virtual reality. We want to leverage how people naturally interact, because the vision that we have of VR as Ready Player One, where people just get in and they interact with the system, is what we want, but we're a ways away from that. So, but the problem is today we can only really do very simple things, and so the current VR and AR interfaces are actually quite primitive. I like to think of it as we're in 1984, where the Mac first came out, and we have a for real mouse or Windows icon menu pointing interface that works. So we now have the first generation VR systems that really work, and now we have to do all that research from there to get to where computers are today. Okay. So 3D interaction is how people carry out tasks in a 3D space, which is different than a normal monitor. The interface is the 3D user interface is the presentation of the methods that you interact with the information, and then the techniques are the particular method or technology that allows you to do that. So where you can say so ray casting would be a 3D user interface, and the technique would be how I implemented that particular sort of ray casting. Okay. So why is this difficult? Well, you're working in 3D space. It took the community, 20 or 30 years to figure out how to use a mouse and keyboard correctly. So now we have another dimension, and we have more degrees of freedom, and we lack constraints, and we have no standards at all, and that's an interesting research problem itself. What is the equivalent of the file menu in VR? We don't have any tools. We have some very basic primitive tools, which are Unity, which are powerful games development tools, but we don't have the equivalent what Motif would be for graphical user interfaces, X windows. We need tools on top of that. Lack of precision. The mouse is you can select an individual pixel with a mouse. You can't do that in 3D. Fatigue. If you wave your hands in front of your face for 10 minutes, your arms are going to fall off. Layout's more complex. Perception. It's just it's 2D but harder. Okay, so so here's a conceptual video of how people in the future would like to use have 3D or have VR construction. So you can please watch the whole video. It's a long video. So you can see he has this really intuitive menuing system. He has really nice gestures. The system understands what he's trying to do. So magic happens. So he quickly builds these spaces, okay? So I encourage you to watch this. This is really motivating video of what the future, what some people would like to be of the future. And what I like about the video is the computer works with the person, but the computer has a very deep understanding of the task that the person's trying to do. So let's look at what we can do today. So this is a very powerful editing tool, but still it's not the same as what we saw in the World Builder. So you can download this today. So we have a long way to go before we get to World Builder. Okay, and we can have a discussion why we're not there, but okay. So let's break it down here. So you need to do 3 things if you're going to interact in a VR system. You need to interact with objects, you need to navigate, move around in the world, and you need to control the application as an application outside of the world itself. You need to load worlds, you need to save files, whatever. Okay, so some things about interaction. So interaction can be broken down into 2 major tasks: selection and manipulation. Okay, so let's have a look at this. So the goal of selection is we want to indicate something. That's with your cursor. You want to point something. You need to query the object to get information about it. You need to make that object active, that you want to apply some action to it. You might need to travel to the object's location. You might to set up to do some manipulation. So there's lots of things that you need to do besides we just highlighted. Okay. So what makes these things difficult? The distance of the object from the user. In the case of a 2D interaction, we don't have this 3rd dimension. So we can interact things within arm's reach, and then you have things that are outside of arm's reach. So we break interaction tasks into basically 2 different zones, and people are looking at having more fine-grained looks at these sorts of things. Okay, the object size, classic Fitts law, smaller things are more difficult to select. Density of the objects in the area. If you have a dense pattern of objects, especially the objects behind objects, to become more difficult to select. And occluders, it's things that are actually preventing you from seeing an object. So if you go into the literature about selection manipulation, there are lots of taxonomies. So as you can see, we have a lot of options that we can pick for when we want to make a selection task. So let's just make this a little simpler. So in selection, we have feedback that you have in fact done the selection. So we can either do that graphically, tactically, some sort of haptic feedback, or audio. I've been playing the game Half-Life Alyx, and they use all of these techniques. The interaction, you can either touch the object, you can point at the object, you can have an indirect selection from a list of menu items. So you can do that. And then you can indicate the selection that you actually want to select. I mean, as in a mouse, we have the concept that we hover over something and then we can actually select it. So we can have a physical button we press, we can have a gesture to do it, or we can use our voice. So as you can see, this space explodes into a number of options that we have. So let's look at some selection techniques. So probably the simplest one is hand selection, where you just go and you actually just touch something with your virtual hand, and it's within arm's reach. And this is the most intuitive. The problem is everything has to be within arm's reach. So you have to physically walk or walk there somehow to get to where it is. It's great when you can do it. Okay. Ray casting, which is, lots of people have seen this, is where you have a ray that comes out of your pointing device to your hand, and then you select something. This allows you to do something outside of arm's reach. And so, you know, you really only need 2 degrees of freedom to do this. It is now kind of the industry standard, but what I think amazes me is that this was what people did at the very beginning, and there are a lot of other techniques, and I'm hoping to see people like you, the students here, that will learn new techniques and put it into into work. Okay. One of the big problems with this is the long lever problem. Is that if you have a ray that goes out, you know, 100 meters from your point, you know, any small twist of your hand will radically change what you're pointing at. So image plane techniques is like it's 1997. So let me show you a video of this. So the idea of this is you reference the image that the visual plane that you're looking at as a way of helping you select things. And so what you do is the hand here is what's between your fingers is what you select. And so what ends up happening is this becomes a very precise way of interacting with things. You don't have a depth cue, and that's called the head crusher technique, for you select things and then you can. Okay, so the idea here is that you use the image in front of your face, and then what you can do is you can map your hand onto that, and then that gives you 2D points in your image plane that get projected into 3 space, and whatever between my 2 fingers is selected, or whatever between my hands here, that's a selection region. It's a very intuitive way to specify an area to select within. Go-Go Arms with Mark Billinghurst was one of the authors of this, and the idea is that if something's not within arm's reach, what you can do is you can interact within arm's reach, but if it's outside of arm's reach, so let's say between my chest and 50% away from my chest is what I interact with, but if I go farther than that, then my hand extends away from my normal position, and then the farther away that I extend my hand, it exponentially grows away from where I am, and so it allows me in one interaction to interact things that are close, and then when I move away from it, it allows me to do with outside of arm's reach to effectively infinity or some long distance away. So these are imprecise, you know, you pick things up and move it around, but sometimes we need to be more precise because we can't, you know, the actual selection, the ray casting is too wobbly. Like my hands shake for all sorts of reasons, but we won't go into that. So we can look at things that are for cluttered, or these ones we're looking at are not for cluttered, and then some are or require more precise interaction. I'm not going to talk too much about the end ones. So cone casting is the idea is if we have this, if we want to select if we want to have a laser pointer, but we want to change the size of the laser pointer, or when it gets farther away, it's not a small dot, it's actually a larger area, we can actually have a flashlight or cone come out from where we are. And then what we can do is we can use a second interaction tool with this aperture, and we can change the diameter of the cone by moving that in and out from where we are. And so then what we can do is we can then go that and select objects. Now, as you can see at the top of this figure, one of the problems of this is it's selected 3 objects, and what you can do is you can reduce the size of it so it only selects one of the objects. So so basically what happens is that if you, so I'll show the video and I'll talk over the video. So we want to select something in this very complex world. Okay, so everything's densely packed. So you know, a laser pointer is not going to allow us to select an individual package. So what's going to happen is they will eventually select a region, and then from inside of this region, this is hard because everything's the same, but imagine they're all different. And what you can do is you basically can go down to this and look at smaller and smaller selections, and allows you to select an individual object. So imagine instead of having everything the same, everything was different, and you select it, and then a group would come in, and then you say, I in fact want to pick this particular object. Whoops. Okay, manipulation. So what we want to do is we want to do the same things that we want to do in a 2D interaction. We want to move things around, we want to group things, we want to scale things, we want to rotate things, we want to apply tools to them and travel. We want to physically move. So once again, we have a lot of choices that we have to make this. So we have exocentric metaphors, which means it's out of body, so kind of a third-person perspective, egocentric first-person perspective, and so we have, we'll go through some of these, but the virtual hands is an egocentric, and laser pointers are egocentric. So what we have here is we have object attachment. So when we manipulate something, when we select it, how are we going to then manipulate the object? We have object position. We want to position the object. We want to change the orientation of the object, and we want to have feedback. And once again, we have a lot of choices here where we can decide how we want to put this manipulation together. Now, these taxonomies are generally made not that somebody sits down, here are all the options, and then we pick one. These options come from people have come up with a number of different ways of tackling this problem. Okay, so some common techniques. So we have, once again, the hand. So this was initially one of the first ways people chose to manipulate objects, because it is the most intuitive way. So the problem with the within arm's reach, it's, you know, when I pick up this mug, it makes a lot of sense. For me, this makes a lot of sense to do that. But if it's not within arm's reach, but I still want to manipulate it. Now, part of the problem is when I manipulate something far away, is I can grow my arms out, but then the problem is, you know, we have this long lever problem again. So what Homer does is it says, select something, bring it close to me, I manipulate it, and then send it back. Okay, and so here's a simple video that kind of shows this. So this is not, when he selects this person, it's a little bit better. So now what happens when he selects the person, he's using his hands as if the position's close to him, and then it allows him to then do a simple, the manipulation. So he's not doing a long lever prop, but he manipulates it, and then it gets sent back to where it was originally was. Similar in the scale world grab, these are all kind of variants of the same thing. And this goes back to a paper in 1997, very famous paper, Moving Objects, sometimes referred to as the Cow's paper. And what happens is that this paper, so what you do is I want to manipulate a building. What I can do is I can shrink the building to being within the size of my hands, or I can grow myself to being a giant and then manipulate the building. It really doesn't make any difference in graphics. And so the idea is I can bring it within close to me, do some sort of manipulation, and then put it back where it's supposed to be. There's the initial implementations have some problems because once you grow and then you move around, you realize that you're not the same size as you were before. If you do this right, it's the world's imperceptible to where it was. Okay. Worlds in miniature. Now, this is, some people call this kind of the gold standard for interaction, for remote or not remote collaboration, for out of arms interaction. So what you do is you have a model of what it is that you want to interact with, and then you interact with that model, and then you push the stuff back out. Okay, so, well, not push it back out, but you have two worlds that are coexisting. So let me show you the video here. This explains it a little easier. So Mark Monet now is a vice president at Disney. So he has this prop, which is also very nice. So he's looking at the world, and he can pick things up and move them around. So as he's moving it around in the dollhouse, it's moving around in the physical world. So what's happening is he can deal with something out of arm's reach, but he's using techniques within arm's reach. So this is a very powerful, not only can he change the objects, but he can change his position in the world also. So we can also use two hands to do this interaction. So we have symmetrical and asymmetrical. So there's this concept of dominant and non-dominant hands. And so the idea is that with your non-dominant hand, you can use that as a reference. In the case of the whim, he was using his non-dominant hand as a reference for the dollhouse, and he was using his dominant hand to be the pointing inside of it. So there's this chaining model, which, it doesn't come out of computer science, came out of psychology. This is a good example of going and diving into psychology and figuring out how people actually think and operate, and then applying interaction techniques based on that theory. Okay, so next we're going to talk about navigation. I better speed this up because how much time do I have, Holger?
You have another 22 minutes.
I'm about halfway. Okay. See how we go. Okay, so navigation. I want to move around in my physical world, and so we need to move, we need to travel to get there, and we need to have cues how to get there. So we have to understand where we are in the world. Okay. So traveling. So we want to be able to walk around. So we have this. We physically have to move between two locations. Okay. So easiest way, if we have a big area, is we can physically walk around in it, but normally our tracked areas are too small to allow us to do that. So we have different types of reasons that we are, we just want to wander around in the world, we're looking for some particular object, or we want to go and maneuver shortly. So in the case of Half-Life Alyx, you want to open up a door, so you have to kind of move around a little bit to be able to physically open up the door, or change movements, or dodge bullets, or something like that. Okay, so once again, the process for this is you have a lot of things that you have to do, and you have a lot of choices. Okay, so you have to start the move, you have to indicate where you're going to go to, you have to indicate the orientation that you're going to take, and then you have to stop moving. Now, it's nice in VR with tracked areas because you just physically move around like you physically do. But if you want to do something more complicated than that, you have to specify a position and a velocity and an acceleration, i.e., if you start moving quite quickly, then it can be quite disorienting. Okay. Once again, the movement process brings in, which I'm not going to talk about, is simulated sickness. Poor movement equals barfing in a bucket, basically. Okay, techniques. So we can do we can use physical locomotion, like treadmills, walking in place. We can have steering metaphors where what direction we're going to go in. Fred Brooks had this great original work where he just took a linear treadmill and then put a bicycle handles on the front, and then that moved you. And it was just a very intuitive, simple way to go about getting people to walk around in buildings. And then we have route planning, where we need to decide where we want to go. We need to specify how we're going to get to where we're going to go if we're not going to physically walk there. And then we have some sort of manipulation to get there. Okay. So here's some treadmills and some other devices that we have. The one on the bottom right is something you can buy today. The center one is one to emulate actual walking, where your feet are going up and down, and it allows you to like climb hills. The ball on the hamster ball on the bottom left was apparently quite effective if you knew how to use it, and if you didn't know how to use it, you ended up falling on the floor and getting tumbled in the ball. Omnidirectional, treadmills, which is like on the upper left. That's you can buy those now for about $50,000. I really like this one on the upper right. And basically, as you walk, the platforms slowly move backwards at the speed that you're walking, and then when you put your foot down, one of those other platforms goes underneath of it. That didn't work all that great, but it's a nice piece of kit. Okay. So once again, we have a lot of choices that we can do for doing this. We have a direction, task, target selection. We have how fast we're going to move, and then what sort of input conditions of control that we have. So let's go through some of these here. So gaze is probably the simplest. This is used a lot in cardboard. Is you just look and you move in the direction that you're looking. It's simple, intuitive, works great. The whole problem is that if you're trying to run forward and you want to look and shoot at somebody to your left, then all you do is start running at your target as opposed to running away from your target and wanting to shoot. So the problem is you can't look in a different direction than you're moving. Teleporting, which is once again an industry standard. For some reason, Facebook and Oculus and HTC, they sort of ignored a whole bunch of years of research. So they think this is the only way to move distances. But it's an effective way to do it. It's actually very simple to implement. So I think that's why people do it. And if you do it correctly, people don't get sick. So another thing that you can do is you can use your actual handheld device to indicate the direction that you're going to move. So what you can do is, as I'm looking to the left, but I can point this device in front of me, and then I can move in that direction. And then as I change my hand, it allows you to change. It becomes quite complicated when you're trying to go somewhere and you're looking at something and you're moving your hand in slightly different ways. So full complete control it's easy to implement and sometimes difficult for people to control. I should point out that a lot of these are assuming that you're just moving over the ground as if you're walking. You can fly. It is VR. Generally what happens when you do something here, and this is kind of a Superman technique where you sort of point your hand in the direction that you want to go. I'm going to fly in that direction. Generally what ends up happening is you can't keep your hand steady and you can't keep it flat. So you tend to rotate your hand. So now you're not only jumping up and down, you're rotating back and forth. And once it's a great way to make somebody sick. So be careful when you have these techniques. There's a lot of new research about how to make it less sickening, and I would encourage you to read about it. Okay. Grabbing air technique, and the idea about this is I want to go forward, so what I can do is I can put my hands in front of me and I grab this air and I pull myself forward, and that moves me forward. VRTK has a technique similar to this where you move your hands up and down like that, and in the direction you're looking, that's like stepping. Stepping in place is another kind of similar technique. Okay, you can move your own body, so world's in miniature, points to where you're going to go, and then you up here where it is, or on a map. These are effective techniques. Generally, what happens with these is people either dim what they see and move there, or they just you know, you have to be careful about having jerky motion between where you are and where you're going to end up. Redirected walking. So this is a big area where of research I'd say in the past 7 years, how to make this work. And the idea is if you have a smaller area of tracking, you can make it seem like you're walking around in an infinite area. And so here's a kind of a demonstration of what it looks like. So this person here thinks they're walking towards the tree, but in fact, the system is tricking them to walk. Okay. So the idea here is that if you had a large enough space, you could have people walk around in circles, but they think they're just walking in a straight line for kilometers. Okay, wayfinding. Okay, the idea of this is that you have a world, but now you need to give people clues about where they're trying to get to. Signposting. This research also goes back to the 90s. Darkin did some fabulous work in the 90s about how do you set up a virtual world and allow people to be able to navigate it. There was a problem what ended up happening, especially in the early days when texture mapping was so expensive. You ended up painting the walls identical. So you have a doom cave and every wall looks the same. So it's very difficult for you to understand where you are in the maze, even if you walked around in it. So wayfinding is a way to help people navigate in areas that they've already been or new areas. And so what you can do to support wayfinding is you can put in landmarks. So a very common technique is either you have something above where you are, and so you can say, oh, I'm trying to get to that tower, so then I navigate through the back streets to get to the tower. Or you stick unique pictures or objects inside the world, even though it's a complicated set of tunnels. You said, oh, I passed that red vase, and now I know where I am in the world. Maps, you know, they're simple to implement and they're easy to use. Now, once again, you have to kind of decide what it is that if you're doing a game and trying to make it difficult for someone to get to the end goal, you don't want to make it easy. But if the goal of this is saying, well, I want to make a virtual shopping center, I don't want to make it difficult for people to get to the store that they want to get to. Okay, so you can have paths, breadcrumbs, and compasses. So these are just some tools, some other tools that you can have. And so here's some simple examples of some. So the bottom left is a set of compasses to sort of kind of give you an idea of what direction you're going in, and then, you know, some paths. These are all just simple ideas, but it's important to put this in if you want to be able to direct people to particular areas. System control. This is probably the least studied area in VR, and it's the idea is like saying, how do we interact with complex data? And so we've been looking at this in terms of things like immersive analytics. So how do you actually control complex pieces of information? It's a tricky problem, but in the simple thing, it's launching applications, changing system settings, files, the pull down menu at the top of your thing. So imagine you had some complex, so imagine you had Unity and you actually wanted to control the entire Unity interface from within your VR system. It would be difficult without a mouse and keyboard, okay? So once again, we have a lot of options. We have physical controls, you know, the things that you put in your hand. We have graphical menus, which can be used over top of it. Voice, gestures. We can build more complicated tools to help you do this. And then obviously multimodal. So, and you don't have to do only one. You can combine these. So here's a good example of the current state-of-the-art menuing system. So the Gear VR, same as the Steam Home or the Microsoft, you know, Home. A lot of times they put this in within a 3D environment to help you orient yourself. Menuing systems. There's surprisingly few menuing systems in the VR community. Tulip was one of the interesting new ones, and basically what you did is you had a pinch gloves, and then you could then use a pinch glove. Is it can detect a pinch. If it's a full pinch glove, it can detect pinches of the different fingers, and you use this as a hierarchical menu. Great idea. Goes back. I mean, these, like I said, people have been thinking about these problems for a long time. We now have the tools to actually do this. So what we can do here is we can actually take 2D menus and put them in 3D space, and sometimes it works. And here's an example of basically just using the thumb pad on the controller and just making a radial menu or pie menu out of it. It's not a bad menuing system. Tools, and so what you can do is you can basically in the case of a cave, you can bring in actually a complicated command center here, and so you can then have this, and so you can have these physical tools to interact with. These, I'm a big fan of physical tactile tools, and some of the work that one of the students that Ross and I are doing is trying to do redirected haptics, so you can actually use these tools within VR but not have to make big control panels. Okay, support size off, the affordance where you're actually grabbing the dial and moving it slightly. These are great interfaces, and I think this is, and the tactile nature of this I think is kind of the future. Voice input, I was actually surprised. I used the IBM voice input for Vive, and it actually works quite well. We need to figure out where voice works into these things. So here's a simple little video.
So early in 2016, when the Vive and the Rift, Oculus Rift, were coming out, I noticed that all these VR headsets, including mobile ones, were coming out with microphones in them, but people weren't taking advantage of voice interaction. And I also realized that voice interaction makes a lot more sense in VR than it does other mediums. And we actually have a really ready-made solution in the form of Watson. And so we put together the VR Speech Sandbox to basically make it easy for developers to build their own voice interaction systems from virtual reality. And in the demo, what you can do is you can create, modify, and destroy objects only with your voice. You can say, create a big black dragon, create a small blue car. You can also use variants, like, you know, give me a big black dragon. You don't need to use a wake word. It's very natural. It accommodates for.
So that's just a nice example of how it can use, but you have to have a nice speech engine behind it. So, okay, so just a couple of takeaways from this. It's the same guidelines really that you have for 2D user interfaces. So avoid mode errors. So if you can make modeless interfaces, that's better. Design so people can don't have to understand the whole interface from the start. Multimodal when you can use it. Has the kind of different for this is spatial referencing for this. So same thing with 2D. You don't want someone's focus and context switching is basically one of the outcomes of that is trying to remember something from one area and then bring it to another area. So just realize I'm running out of time here. So so the last thing I want to talk about is how do you design for these things? And I'm going to give you a very high level design process, which I'm sure you've seen before. And so the idea is, so how do you, we want to make VR or AR interactions useful. So this is one model for the design process. And if you notice, it's a circular model, and you can, not all the arrows go back to every place else. This is a model of, but the idea is that you go through these 4 processes and you keep iterating until you come up with a solution. It's not too different than an agile design process. So you have to understand who the users are, and you have to understand what their requirements are. And then you actually have to ask the question, can VR actually address these things? Because VR doesn't solve all problems. So I would hate to have to write my PhD thesis, with an HTC Vive. It just, would give me, I get a headache just thinking about it. Okay, so then we have to go through the design process. And so design, I spend a lot of time working with designers, and I quite enjoy it. It's a big area of research within the center. And so basically you have these 2 competing goals. One is elaboration, constantly thinking of new ideas, constantly expanding out of new ways of doing it. And then you have to make it, at the end of the day, you have to do a reduction to say, well, we have to come up with a final design. And so basically what you're doing is, throughout this design process, this shows a linear model. Actually, the model that they use in the design school at UNSA is a double diamond, but it's also, inside of this is lots of iterations. So a couple of tools that you can use is metaphors. So you can, like a task list is a metaphor, a bookcase is a metaphor, the desktop's a metaphor. Although somebody once pointed out that if you actually had if you had a real desk, and if you put a piece of paper down on a particular area of it and it just disappeared, that would freak most people out. So the idea with metaphors is if you get the metaphor right, it's easier for them to navigate. Affordances, this is something that Bill Gaver pulled out from a psychologist, Gibson, or an industrial designer, Gibson. And the idea is that if you look at something and by looking at it, you understand how you're supposed to use it, this is a really powerful way for designing things. So I keep going back to the Alex Half-Life. What they do is, if there's a handle you can manipulate, it's painted red and it's very obvious. And they don't put any handles on doors you can't open. So that's a very simple metaphor. I know it sounds very, but at least it tells you what you can and can't do just looking at it. Next, you want to build an interactive version to tests. And so what we can do is we want to prototype. So there's all sorts of levels of prototyping, from paper and pencil to building a full Unity app. And this is an iterative cycle that you normally go through. And the nice thing about VR is there's a lot of tools. I wish I had time to put this in here, but there are a lot of tools that you can quickly knock up a simple example to show your end user. And finally, you want to evaluate this. Okay, and there's lots of evaluation things that you can do. Quick and dirty usability testing. All the universities do this now, and it's based on psychology testing, but also labs do this, and companies do this. Field studies, and then bringing in experts and do predictive evaluation. So I think I did it right on time. Is that right?
That's absolutely correct, Bruce. Thank you very much.